nanohub.org.
Online simulation and more for nanotechnology.
One of the things we talked about last time was this concept of incubation, where you're working on something but you haven't had it quite figured out, but your brain keeps working on it when you go off to do something else, especially when you're sleeping. So I gave you 3 little puzzles that might require incubation. So this one was move 3 dimes to form a downward looking triangle. And I couldn't figure this out when I was looking at it, and then I woke up the next day and I had a solution. I moved 3 dimes and I had a downward looking triangle. Needless to say, that wasn't what they were looking for, but I thought mine was pretty good. So what they were looking for was moving these 3 dimes. Everyone figure that one out? Okay, this one was pretty simple. This equation contains 3 errors. Well, there's 2 spelling errors and the statement is incorrect. So it contains 3 errors, not 2 errors. Oh wait. No, it contains 2 errors, not 3 errors. How about this one? I had a program manager at Office of Naval Research. He always liked to say, think outside the dots, because everyone used to say, think outside the box. So he was especially pleased when people looked at him puzzled, and he would show them this one. So there's 1 line, 2 lines, 3 lines, 4 lines. Okay. I'll give you another one that you can take home. 6 equal length pencils form 4 equilateral triangles with them. Okay, so these are the topics we're going to talk about today. And they make sense when you think about the brain, because as we said last time, the brain weighs about 3 pounds, so it's about 2% of your body's weight. But it's consuming 20% of the air you breathe and 20% of the fuel your blood is pumping. And you only have to cut that supply off for 10 seconds and you're unconscious. So that's why if a fighter pilot pulls out of a dive too quickly, the blood can't pump the blood to the brain because of the centrifugal force, or if they're in a centrifuge and they black out. Okay, sleep. Well, there's 2 things that determine sleep. You have this normal circadian rhythm, and there's also a chemical that keeps building up as you're awake, adenosine. And for instance, the way caffeine works, caffeine outcompetes the adenosine molecules for the receptors that gives you this feeling of sleep pressure. So even if you're drinking coffee, it doesn't reduce the adenosine, that just keeps building up as long as you're awake. Now there's 2 things with lack of sleep. The first one we'll talk about and mention some things you're probably very aware of. But the thing you probably don't know much about is the learning that occurs during sleep. Okay, so effects of lack of sleep. So you probably have been tired and you had this trying to remember something and realize you have difficulty doing it. It's hard to concentrate. Your immune system is impaired. Emotional problems. People get cranky when they haven't had enough sleep, and that's because their amygdala, the region in the brain that controls things like fear and aggression, acts up. Scary one is these metabolic contaminants that build up. Not only the adenosine, but all this fuel you're burning, those contaminants stay in your brain until you sleep. Increased stress hormones like cortisol. And it's well documented that the chronic lack of sleep leads to things that can eventually kill you, like cardiovascular disease, type 2 diabetes, strokes, and so forth. Okay, but there's also things that can kill you quicker if you don't sleep. And they don't do these experiments anymore because they wouldn't get beyond any internal review board, but they've kept animals awake like dogs and rats, and they eventually die. And when they autopsy them, they find that there's been degeneration of the nerves in the brain and the spinal column. Okay, so in your brain, you have a system called the glymphatic system, and this was discovered less than 10 years ago. And this is what removes all those contaminants. And it mainly occurs while you're sleeping. One of the things, for instance, it removes is this thing called amyloid proteins. And people who have had Alzheimer's and die, they find there's a lot of amyloid proteins in their brains. So sleep cleanses your brain. The other thing that happens if you don't get enough sleep is these things called microsleeps, where you are actually unconscious for, a fraction up to a second, and you don't actually know it. And in fact, most causes of accidents from drowsiness is not because people actually fall asleep, is they go unconscious for half a second or so traveling at 70 miles an hour. So here's a study that looked at these microsleeps. So the way they tested people is they had a screen and there would be a light that would flash. And every time a light flashed, they'd have to push a button. And so the computer kept track of, did they catch everyone and what was the delay between the light and when they pushed the button. Okay, one group that got 8 hours of sleep every night pretty much got all the flashes over a 2-week period. Then they had a group that had no sleep. And as the days progressed, they were missing more and more of the light flashes. And they stopped after 72 hours because that was probably all they were allowed to do. Then there was also a group that over 10 days, they limited them to 6 hours of sleep every night. And what they found was that after 10 days of just 6 hours of sleep, they were missing as many as someone who had stayed awake for 24 hours. And they weren't aware they were missing them. They said, I didn't miss any of the lights. I saw them all and hit the button. That's because they were unconscious briefly. Now, Eugene Azarinsky was a graduate student of Nathaniel Kleitman's at the University of Chicago. And Kleitman's like the father of sleep research. And they were looking at infants sleeping and monitoring this rapid eye movement that was occurring. And they also were looking at, they had some electrodes to their brains, watching the electrical signals. And they discovered these sleep cycles. That people have these cycles that are about 90 seconds long, where you fall asleep, you go into a deep sleep, you come out of it into REM sleep, back into deep sleep, out into REM, deep sleep, out into REM, so forth. And they discovered that the first 4 hours of the night, you get more deep sleep than anything else. And most of your REM sleep occurs in the last 4 hours. And this is important because different things happen during deep sleep and during REM sleep. And the way you distinguish those is with the frequencies of the brain waves that are occurring. Okay, so stage 1 is 8 to 13 hertz, stage 2, 4 to 7. These deep sleeps are less than 4. And the frequencies during REM sleep and when you're awake, you found were very similar. It was hard to distinguish between them. And then one other thing occurs we'll get to that is important. You get these bursts of higher frequencies that are called sleep spindles. Okay, so we'll come back to see what those do in a little bit. Actually, pretty soon. Okay, so what they've done is they've had people study something and then they put them in an MRI. And they see a lot of activity in the hippocampus and the rest of the brain is kind of quiet. Then they let them sleep. And they come back the next day, put them back in the MRI, and again, look at the material they were studying the day before. Now the hippocampus is very quiet. And it's the neocortex that is very active, regions in the neocortex. So during sleep, the information transferred from the hippocampus to long-term storage areas. And that's why Henry from last time, who had part of his hippocampus removed, probably couldn't form any more long-term memories. The other thing they correlated with how much people transferred was how much deep sleep. Because they would have people learn something, and then when they slept, they monitored how much deep sleep they got, and then they could predict how well they would perform on a test the next day by how much deep sleep they had. Okay, so during the day, you're learning things, information goes in your hippocampus. Then at night, in the first half, during deep sleep, things get transferred from the hippocampus to your neocortex. And I won't go into the studies, but not everything gets transferred. It turns out you kind of tag things during the day as being important or not important. So not important things like where you parked your car, you don't want to remember that, 6 months from now. So you don't really transfer that to long-term memory. But then something else has to happen because your hippocampus has to be cleared out for the next day. And they've correlated that with the sleep spindles in the last 4 hours. And the more sleep spindles they found, the more people could learn the next day because they've had a more empty hippocampus ready to bring in more information. Now remember, REM sleep occurs during the last 4 hours, and something real important happens during REM sleep. For instance, this incubation I talked about when you're sleeping, that's probably where this happens, where you figure out, complex problems. It's where information you learn during the day, you figure things out related to it more deeply and connect it to other things you know. So here's an experiment where they had rats running a maze, and they put in electrodes in the brains of the rats so they could monitor the electrical signals. And the researchers were able to tell, looking at the electrical signals, where the rats were in the maze after the rats had learned the maze. Then when the rats were sleeping, they saw the electrical signals of the rats running through the maze. So the rats were rehearsing the maze while they were sleeping. So they were reinforcing what they had learned during the day. So here's a study with people where they took 102 undergraduates who had never taken an econ course. Split them into 2 groups. So group 1 watched a virtual lecture in the morning and 12 hours later took an exam. Group 2 watched the same lecture at night, then took the exam 12 hours later after they had had a full night's sleep. So on problems that were similar to the lecture and just kind of recall, those who slept did, I think it was about 8 percentage points better, so that's pretty significant. But on problems where you had to interpret something from the lecture to answer a question, those who slept did much better than those who were awake. So somehow during their REM sleep, they somehow learned that material much deeper. Okay, so here's another one where they taught these subjects how to solve a particular math problem, and they gave them a very tedious method of doing it. And there actually was a much simpler method. Okay, so they taught them how to solve it, and then they came back 12 hours later to solve some more problems. So group 1 learned how to solve it in the morning and came back in the evening. So that's the awake group. So they came back in the evening and took the test. Group 2 learned it at night, slept, and took the test in the morning. So for the group that didn't sleep, 23% of them found the simple, quick way to answer all these math questions. For the group that slept, almost 3 times as many figured it out. So they probably figured that out mainly when they were sleeping. Okay, here's another one. So these participants learned a novel artificial grammar to where they could have like a 90% efficiency. And then a week later, they were tested on the grammar. So group 1 slept naturally for that week and consumed no alcohol. And they pretty much maintained their proficiency. Group 2 consumed 2 to 3 shots of vodka, depending on their body weight, the first night, but no other alcohol during the week. And group 3 consumed 2 to 3 shots, but on the third night. So group 1, as I said, maintained their efficiency. Group 2 that had the alcohol dropped to 50%. And the group that had the alcohol a couple days later down to 60%. The greatest suppressor of REM sleep is alcohol. Okay? So that's probably what accounts for these results. Okay, so people who, here's another study. They had people study in the morning, and they had them study all sorts of different subjects, whether it was straight retention, comprehension of deeper structure, whatever. And they found after a nap, the ones who napped performed about 30% better than those who did not nap. Okay, let me do one more. Okay, so here these participants studied a virtual maze and figured out how to get through the maze, and they timed how long it took people. Then they split them into 2 groups. So one group did something else, whatever they wanted for 90 minutes. The other group took a nap. And at 3 points during that 90 minutes, they interrupted this group and asked them what they were thinking about, or they woke this group up and asked them what they were thinking about. So the ones who were awake, but when they were polled said they were thinking about the virtual maze, performed better, like 50 seconds faster going through the virtual maze than the ones who were awake and didn't think about it during that 90 minutes. The ones who were sleeping, the ones who, when they were awoken, said they were dreaming about the maze, they were almost 400 seconds faster in their performance. Go to mindsets. Okay, so here's a Kelvin and Hobbes cartoon, and Kelvin comes up to Susie and asks her what she's doing. And she explains how the homework assignment was really hard and all that she had to do to be able to do the homework assignment. And Kelvin goes, "You do all that work?" And she said, "Yes, now I understand it." And Kelvin says, "I used to think you were smart." So Carol Dweck has spent, 30 plus years studying mindsets, and she groups people into 2 different mindsets. This entity or fixed mindset and the incremental or growth mindset. So the fixed mindset, and I think because you're here in this room, I'm sure you all have a growth mindset. But fixed mindset people think effort means you don't have the skill or talent. And they're more concerned with proving how good they are at something than putting in the effort to learn. If you fail at something, it means you're not smart. And so they don't want to put themselves in positions of failing. So if they have a test, they know they're not going to do well, they might do something to self-sabotage and have an excuse, like stay up all night, partying or something. So, oh yeah, I got a D on it, but I was up all night having fun. Or they might not take a course that they're real interested in because they've heard the course is hard and they don't want to take a chance that they might get a B instead of an A. Okay, growth mindset people realize that everyone has different talents, but with effort, you can become good at whatever you undertake. They're concerned with improving, doing this deliberate practice to get better. If they fail at something, it means they have more learning to do. They need to figure out a better way maybe to learn. And that true potential is unknown and that it takes time to develop to see how good you can get at something. So do you believe your intelligence is fixed or something you could develop? So the way you answer this will tell if you're you have a growth or fixed mindset. And intelligence can be developed. Okay, James Flynn, a New Zealand psychologist, discovered something interesting. If you give someone an IQ test that's designed for today, IQ tests are designed for the average to be 100, and someone gets 100 on it, and then he gives them an IQ test from 50 years ago, they'll get 115 on it. So people have gotten smarter. Probably our educational system, it's attributed to people probably being able to think more abstractly today. And you can become more intelligent because the brain is remarkably plastic. That means it can change and grow at any age. Okay, neurons are actually born, even in my old brain, every day in the hippocampus. Your dendrites are growing and sprouting and synapses are forming. As you've been listening to me today, your brain has changed. You form these connections between neurons. You can form new blood vessels with exercise, for instance. And that's important because you got to get all that fuel to your brain. Now, the first person to discover that neurons are born in an adult brain was Joseph Altman. So back in the 60s, and as it turned out, 70s, 80s, and most of the 90s, no one believed that the adult brain generated new neurons. So Altman was either ignored or ridiculed, and he ended up not getting tenure at MIT. He actually ended up then at Purdue for the rest of his career as a professor here in biology. But in the late 90s, neurogenesis in the adult brain was rediscovered. Okay, and I'll show you some scans of that a little later. So here's a study showing changes in IQ, whatever IQ means. So they looked at these adolescents at the beginning of a 4-year study and measured their math ability, their verbal ability with standard IQ tests. And they did MRI brain scans. And when they came back 4 years later and retested them, some students performed better, say on the math portion of the IQ. So somehow they had raised their math abilities. Some performed better on the verbal part, so they improved their verbal abilities. And when they looked at the brain scans, they saw for those with the increased math ability, when they were doing math problems, a larger area of the brain was being involved. And the same with those who improved in the verbal area. A larger part of the brain was being involved. Okay, so I'm going to be showing some MRI scans, and just want to mention Edward Purcell, who discovered nuclear magnetic resonance, which is the concept used in MRI machines. And the reason I like to put up his picture is he's a Purdue BSEE. Okay, so here was a study of London taxi drivers. So to become a London taxi driver, you have to pass this exam called the knowledge. And it takes about 4 years of study for someone to pass it. So you must know an area of 6-mile radius. So there's like 25,000 streets, and if you've ever been to London, the streets go every which way. It's not a grid or anything. They must know the most efficient route between any 2 points, and that may include crossing the Thames River once or twice. You must know the location of every landmark. So they did MRI scans of their brains before and after, and what they found was for those who passed, there was a substantial increase in parts of their hippocampus. So they actually grew that portion of their brain when they were working in memorizing all this knowledge of the layout of London. The other thing it's known is that if someone becomes blind, the area of the brain that used to be used for sight starts to be used for other things. So a blind person's sense of touch will get better, so they can read Braille as they practice, and they start using portions of the brain that used to be used for vision to improve that sense of touch. And the same thing with their hearing. So what I'm trying to stress is that the brain is really plastic, meaning it can really change. So here's a study that Carol Dweck did when she was still at Columbia, where she took students who were in pre-med chemistry. And she gave them questionnaires and determined whether they had a growth or fixed mindset with questions like, do you believe your intelligence is fixed or something you can change? So those she categorized as fixed mindset, they did poorly in the course. And then when she surveyed how they studied, she saw what we talked about last time, poor study techniques. They would just reread their text and notes and try to memorize how to solve a problem. Those in the growth mindset category did much better grade-wise, and they studied totally different. They were looking for themes and underlying principles. They were studying to learn, not just how do you solve this particular type of problem. Okay, so here's one where Dweck showed that you can quickly change someone's mindset. So these were a group of 5th graders, and they were given a non-verbal test. I think it was probably like a math question test. And it was difficult. The average was 5 right out of 10. So she divided them up in 3 groups, and in one group she would go to them and said, this was a really tough test. Your ability to get 5 right means you are really intelligent. You must be really smart. She went to group 2 and said, this is a very tough test. You got 5 right. You had to work really hard and put in a lot of effort to be able to get 5 of these right. And the third group, she said something like, oh, I really like the shoes you have. Those are nice shoes. You know, nothing pertaining to intelligence or mindsets. Then they were given another test that was much more difficult, where maybe they got 1 or 2 right. And then they took a third test, which was similar to the first one. So those she told were smart went from about a 5 to 4.4 right. So they dropped. Those she praised for effort went from 5 to 6.81 correct, more than a 30% improvement. Improvement in IQ, essentially, right? It's not questions from an IQ test. The nonspecific praise stayed around 5. She was so surprised by these results, she repeated the experiment 5 times, always getting the same results. Okay, one more striking result. She told these children that they were going to go to another school and do this, to write a couple sentences describing your experience and tell them what score you got. For those who were in the fixed mindset, 40% of them lied about their score, and then they lied in the direction of increasing the number they got right. So it's that fixed mindset. You have to prove you're smart. Okay, one more of Dweck studies. So these were kids entering 7th grade. And they were divided into 2 groups. So one group had 6 sessions on different aspects of learning. The other group had 6 sessions, some on aspects of learning, but some on talking about how the brain is plastic, how it can change, and how you can become smarter with effort. And at the beginning of the school year, their incoming GPAs in math were around 2.5 for both groups. At the end of the semester, the group that was just taught to about study skills decreased. Their grade in math dropped from 2.52 to 2.37. Those who were told about the growth mindset increased their GPA from 2.54 to 2.68. So at the end, that was a 0.3 GPA point difference by putting one group in a growth mindset path. Okay, so let me give you one example of someone who had a growth mindset. This person earned a C- in high school English. His SAT verbal score was 475. That put him in the bottom third. Took him 5 years to graduate high school. He read much slower than everyone else, and he had difficulty spelling. And he wanted to be a novelist. So he kept working at it. Maybe it took him 3 times as much effort to become a novelist as someone else. But once he had that writing skill, but if he still kept putting in 3 times the effort as some other novelists, he's going to do much better, right? So this person was John Irving. He's written 17 novels. His book, The World According to Garp, won the National Book Award, was made into a movie. His book, The Cider House Rules, was made into a movie, and he got the Academy Award for writing the screenplay to that movie. Okay. So, if you really want to accomplish something, with effort, you can do it. Okay, self-control and grit. Never put off till tomorrow what you can do the day after tomorrow. Okay, we've all been guilty of procrastinating. Procrastinators, it's found, have higher levels of stress. That's not surprising. You wait till, oh, my test is tomorrow, I better start studying. Worse health, because you probably stay up late at night doing that studying or to get that assignment done or ready for the test. Lower grades, because you didn't do space studying. So here's a famous experiment done about 50 years ago at Stanford. It's called the Marshmallow test. So they brought these preschoolers into a room that had a table and a chair, sat the preschooler down, put a plate with the marshmallow on it. Actually, the preschooler could pick which treat they wanted. And then the researcher explained to them that marshmallow was theirs. They could eat at any time. But if they waited for them to come back in the room, they were going to leave the room and then come back, they would get 2 marshmallows. And the idea of the test was to see what the children would do, to try to wait that 15 minutes. Well, some children just ate it right away. About a third of them waited the 15 minutes. And they did things like sit on their hands, look everywhere except at the marshmallow, or start singing songs, anything to distract themselves to get to that second marshmallow. So when these children were high school seniors, they looked back and saw that there was a strong correlation with how long they waited for the treat and how well they performed on the SAT. They interviewed the parents and teachers and found the children who waited longer were rated as having more self-confidence, being more positive, being more successful. And then they did a follow-up study, I think in 2011, where they saw that again, the more successful in their careers were the people who were able to wait longer. Okay, so there are some caveats because it was a small group. It wasn't a very diverse group. They were all children at the preschool at Stanford, so their parents were either faculty or graduate students. I still think it's not hard to imagine, though, that if you can resist temptation, like your friends tonight say, let's go to a movie, and you say, no, I have a homework assignment due tomorrow. You have the self-control to say no to going to the movies and doing your homework. Okay, so here's a study where they looked at 263 students who were told to study something for 15 minutes, a short amount of time. So the researchers watched them and noted what they were doing once a minute. It only took about 2 minutes for a lot of them to start doing something else, like checking their texts or looking at their Facebook page or something. And they found that out of 15 minutes, they were only on task for about 65% of the time. And this study showed that there's a direct correlation, a negative correlation with GPAs and how much texting and use of Facebook that someone does. So maybe the new Marshmallow test of self-discipline is the ability to resist that blinking inbox or that buzzing phone. Okay, grit. Angela Duckworth is a professor at the University of Pennsylvania, and she studies grit. Okay, and this is where you have passion and perseverance for something that you work maybe years or decades to accomplish, like John Irving had to do to become a novelist. So it's not the same as self-control. You need self-control to ignore those momentary attempts to distracting you, but it's much more. And it has to be something you have a passion for to be able to put in these long periods of time. Okay, so this is just a summary of things I just said. Okay, so this is Duckworth's grit math. So everyone has a different talents, but if you have less talent, you can put more effort in and get a skill, like John Irving did with his writing. Then if you take that skill and you're putting in that effort again, you get to achievements, like the novels he wrote. So effort gets squared in going from your talent to your achievement. So the effort is much more important than your starting skill level. So here's a study that Anders Ericsson did. He's the guy we talked about last time with Steve Falloon and Remembering Digits, who determined that this deliberate practice over extended periods of time is what makes someone successful. So he went to the Berlin University of the Arts, and famous music school, and he asked the faculty to divide the students into groups. Like, tell me the ones you think are so good they're going to be international soloists. And then give me the group that's good and will probably end up playing in an orchestra like the Chicago Symphony. and then tell me who's left who will probably spend their lives teaching children how to play the violin. Okay. Then people who go to this school do a lot of practicing, and you keep track of what you're doing. So they had a pretty good handle on how much time they had spent practicing the violin. So he polled them and got that information, and then he made this plot. And he found at any age that the best students put in much more practice than the good students who put in much more practice than the ones who were destined to just be teachers. So at least for this group, what was differentiating them was not the talent, but it's the practice they had put in. And he also polled some professional violin players, and their data was very close to that of the best students here. He also asked them about their sleep. So here's the best students' sleep. So they slept more than the good students, and they even took naps. And the ones who had the least sleep were the ones in the category of being teachers. People who have grit have a growth mindset. You have to, because you have to believe putting in all this effort, you can keep getting better and better at what you're trying to do. Okay? So these things all kind of tie in together. And you can get grittier, you can improve your self-discipline. These are personality traits, and only about 30% of these personality traits are determined by your genes. About 70% of it is determined by your environment. Okay, so for instance, culture can instill it. So if you have some friends and you have a homework due tomorrow and they say, let's go to a movie, and you say, no, you're going to stay home and study, and they go off to a movie, find other friends who are grittier who will stay home and also study. Thinking of yourself as gritty can help. Okay, it's the fake it till you make it approach. Engaging in an extracurricular activity and sticking to it for at least 2 years turns out to help that people who do that display being grittier, especially if they've accomplished something in that, like become an officer in that extracurricular activity or something like that. And Angela Duckworth, when she looked at applications to college and once accounting for the students' grades and SATs, she found the one thing that really determined the success was if this occurred, that 2-year extracurricular activity in high school. Make a list of tasks for tomorrow. Okay, it turns out that there's a strong psychological influence on us. If we write something down that we're going to do this and this tomorrow, that we will follow through and do it. Meditate. We'll talk more about that a little bit later. Routines. So have a routine of this is when I'm going to do this every day. For instance, I come into work at 7. And by 3:30, I've usually had it, so I go home and I exercise. Do that every day. If I get stuck at work and I don't leave till about 4:30, I'll get home. I often don't exercise because I missed my routine. It's like, oh, it's too late now. I'm more tired or whatever. And then there's this Pomodoro technique that Frank Cirillo developed. And it's called this because Pomodoro is tomato in Italian, and he had this tomato-shaped kitchen timer. So what he did to get himself to have discipline to accomplish something is he'd set the timer for 25 minutes, and you turn off your cell phone, close Facebook, and just, spend 25 minutes doing your task. But when the timer goes off, quit for a while. Do something else for a while. That gives yourself a chance to have some incubation occur. And then come back if you have more to do, and try to do it in these short bursts to start trying to develop this self-discipline. Okay, exercise. Okay, exercise is very, very important for the brain. It improves circulation, so delivering all that fuel to your brain. It turns out it spurs the production of neurotransmitters, so it improves the speed with which you think. It facilitates the synaptic plasticity, and it boosts levels of something called brain-derived neurotrophic factor, BDNF. Your muscles actually put this out when you're exercising. And in the brain, it helps, it's like fertilizer for the brain. So for these new neurons that are being generated in your hippocampus, it helps keep those alive. It helps with the dendrite growth, synapse formation, and so forth. So here's an example. So they had mice, and this group of mice were put in a cage, and they got food and water and nothing else. And these spots are new neurons in their brains. The second group of mice, similar cage, except it had one additional thing, a running wheel. And that additional exercise led to a lot more new neurons in the hippocampi of these mice. And you might say, okay, so mice can get smarter, their brains can grow. How do you know people can? Well, they did that experiment. So at the University of Dublin, they took some sedentary students. They made them exercise for 5 weeks, strenuous exercise on an exercise bike. And they did MRIs before and after the 5-week period. So this is what they saw. This is one student. Here's the hippocampus before the exercise. Here's the hippocampus after the 5 weeks of exercise. I don't need to be a radiologist. I can see that it's grown. Here's another group. These were older people, 60 to 79. And they split them into two groups. One group did aerobic exercise, and the other one just did stretching for 6 months. Then they did brain MRI scans before and after. Those who did the aerobic exercises had more gray and white matter in the frontal and temporal lobes in the brain. So that exercise caused growth in those brain regions. Meditation. You can think of this as strength training for your brain. And this is one area, it's probably the simplest one to do, and it's the one that I probably fail the most at. And it does a lot of good things for you. Relieves stress, it heightens your awareness, strengthens concentration, and probably the most important things, help you ignore all that mental chatter in your brain. Okay, so this is what happens during meditation. And all you have to do is like 10 minutes a day, sit in a comfortable chair, close your eyes, and take deep, slow abdominal breaths. And pay attention to the breath. Like, pay attention to your abdomen going up and down, the air going in and out of your nose. And the first time you do this, you'll find before even a minute is up, you're thinking about something else. You're thinking about, oh, that date I have tomorrow night, or this homework assignment that's due next week, or something else. But then you realize at some point, you're now daydreaming about something. And you bring your focus back to your breath. And that's part of this process of what meditation does for you. It's noticing you've lost concentration and bringing it back to what you're trying to concentrate on. So they did a study at Harvard with 16 adults over 8 weeks. So they had classes on meditation, and they meditated for 3 hours per week. So that's about 25 minutes a day. Okay, so that's quite a bit. But they only did it for 8 weeks, and they were able to see visual changes in the brain with MRI scans. There was an increase in gray matter around the hippocampus, and there was also a decrease in gray matter around the amygdala. Remember, I mentioned that earlier. That's the region of the brain that's involved in like fear and emotional responses. And there was a study at UCLA where they went and they found people who had been meditating a long time, like 10 or 20 years. So UCLA was probably well situated to find a lot of people who meditate. Right? So they scanned their brains, and they scanned brains of similar age-controlled people who didn't meditate. And what they found was that those who meditated had a lot less loss of brain matter, a lot more gray matter, a lot more purification of their cortex. And that's believed to be more purification, the better the brain is at processing information. And then just another quick mention, there's a study done at University of Pennsylvania where, again, they found that experienced meditators have significantly higher blood flow to the prefrontal cortex and some other regions of the brain. Okay. Before I start nutrition, I want to jump back to sleep one more time because there was something I forgot to mention. Okay, so a lot of creativity can happen when you're sleeping. Okay, Mendeleev says the periodic table came to him when he was sleeping. Mary Shelley, who wrote the novel Frankenstein, came up with that while she was sleeping. And everyone know who Keith Richards is? The Rolling Stones? Well, he keeps a recording device by his bed because he often wakes up and has a tune in his head. And he has a guitar there. He records it. So it'll be there in the morning when he wakes up. So back in the 60s, when he was recording with the tape recorder, he woke up one day and he saw the tape had completely run. And he didn't remember getting up. And when he played the tape, the music to the song Satisfaction, probably one of their biggest hits, was there. So he somehow did that in his sleep. Okay, nutrition. Okay, the brain is about 75% water. So you need to keep hydrated. So that's one of the simplest things you can do. So there are many studies showing that just a little bit of decrease, if you're a little bit thirsty, you don't think as well. Get that water from water. Don't drink soda or fruit juices. Those are filled with sugar, and you'll learn that those are toxins today. Don't drink caffeinated beverages. Okay, caffeine dehydrates you. So get your water from water. Of the rest of your brain, 60% is fat. And it's not the fat you think of like as stored energy sources. It's more structural. It's the insulation, the myelin sheath around the nerves. So let's talk a little bit about fats. Okay, saturated fat is one where all the carbon bonds are single bonds. So it's saturated because you can't add in any way more hydrogen atoms to the molecule. A monounsaturated fat has one carbon double bond. So you could actually force 2 more hydrogen atoms on it. So that's why it's monounsaturated. Polyunsaturated have 2 or more double bonds. And you've all heard omega-3s, omega-6s, maybe? Well, a fat molecule has an alpha and an omega end. If the first triple bond is the third one from the omega end, it's an omega-3 fatty acid. Now, this is a trans fat. One of the worst things you can consume, one of the things the food industry loves to put in our food. Okay, so polyunsaturated fats are liquid at room temperature. You can turn a polyunsaturated fat into a saturated fat by hydrogenating it, forcing hydrogen atoms on here. And saturated fats are solids at room temperature. So by the amount of saturation, the food industry can get what texture they want. So for instance, margarine, solid but easy to spread. In the process of hydrogenating a fat, this polyunsaturated fat is not really straight. It's bent where there's that double bond, and you can't get the other 2 hydrogen atoms in there until it changes from this thing called a cis configuration to the trans configuration with the hydrogen hops on the other side. Then the thing straightened and you can add the other hydrogen atoms. But as I said, they don't fully saturate them all. They leave a lot of them as trans fats. And you don't consume it without the processing to get the trans fats. If you eat foods that aren't processed, you get virtually no trans fats in your diet. So this was a review article. And let me just, a lot of bad things that trans fats do to you, but let's just look at what they do to your brain. In the summary in this abstract, trans fats have an adverse effect on the brain and nervous system. Trans fats from the diet is incorporated into the brain cell membranes and alter the ability of the neurons to communicate. This can diminish mental performance. Relationship between trans fat intake and depression risks are observed. There's growing evidence for a possible role of trans fats in the development of Alzheimer's disease and cognitive decline with age. So avoid trans fats. Now, omega-3 and omega-6 fats are good fats. They're very necessary to have. The problem is in the modern diet, American diet, the ratio of omega-6 to omega-3 fatty acids you get are typically on the order of 25-1. 20,000 years ago when we were hunter-gatherers, it was more like 1-1. They both perform important functions, regulatory functions, but kind of opposite. So for instance, omega-3 promotes blood fluidity. So your blood flows and it doesn't clot, you don't get a heart attack, you don't get a stroke. But if you cut yourself Omega-6 promotes clotting over of the injury. So that's why you want to balance there. Omega-6 is a vasoconstrictor. So too much omega-6 and you get high blood pressure. Omega-3 is a vasodilator. It's almost impossible to, but if you got too much omega-3, then your blood pressure gets so low you'd faint. For our brains, the important thing is that omega-3 is an anti-inflammatory, omega-6 is a pro-inflammatory. Now, if you have an injury or you're an illness, you want inflammation that fights the disease or goes to heal the wound. But you don't want chronic inflammation, that is, inflammation all the time throughout your body. It kills nerve cells, kills them in your brain. People with diabetes, you probably know that one of the things that happens is their extremities become numb. That's because of the inflammation killing the nerve cells. Okay, so how do you get a good omega-6 to omega-3 ratio? Wild-caught cold water fish is a good way, not farm fish. So for instance, farm salmon has a ratio of omega-6 to omega-3 of 14 to 1, where wild-caught salmon is like 3 to 1. Grass-fed beef has a ratio of omega-6 to 3 of 2 to 1. Grain-fed beef is like 8 to 1. If you're eating eggs, you don't want them if they're from chickens who've been fed grain. So, grain-fed beef, grain-fed farm fish, grain-fed chickens you want to try to avoid. So, two types of omega-3s found in these foods are called EPA and DHA. They're long chemical names, but DHA also aids with exercise in the promotion of this brain-derived neurotropic factor, this brain fertilizer. Okay, here's some oils that are high in omega-6, so you want to avoid them. But there's even a bigger reason you want to avoid them. When the vegetable oil is part of the vegetable, it's fine and stable. But when it's extracted, it's not very stable. And what that means is it can easily become a trans fat. It can easily become something like a free radical. And both of these attack cells in your body. They'll change DNA, they will change proteins, etc. So you especially want to avoid foods that are fried in these oils because the temperature causes even more trans fats to form. The myelin sheath that's around your nerve cells, which help facilitate the speed and signal quality, part of it is made up of monounsaturated fatty acids. So here are some foods that provide those. Probably one of the most important one is this extra virgin olive oil. And this study right here was a 6-year study where they had a control group and another group who consumed 1 liter of olive oil every week. And after 6 years, they found cognitive improvement in the group that had been consuming the olive oil and decline in the other group, probably age-related decline because of the 6 years. Okay, refined sugars. These became available in the early 1800s. Before that, the only sugars people could eat would be berries when they were in season. They're not chock full of sugar, but they have sugar and they also have fiber, which slows down some of the bad things that happen with sugar. By 1900, Americans were consuming 26 pounds of sugar every year. Today, it's more like 160 pounds of sugar. Sugar's in everything. You have about 5 liters of blood, and you have a little less than 1 teaspoon of sugar in your blood. And that's tightly controlled by the pancreas, which if you eat something and there's an increase in sugar, it puts out insulin. Insulin tells cells to take in the sugar, like your muscles to store for use when you start exercising, to your liver to store as glycogen in the liver, which is another fuel supply you call on when needed. And if there's even more sugar, then some of it is converted to fat in the liver, some of it stays in the liver, some of it's sent to your adipose cells. Glucagon is the chemical that the pancreas puts out if your blood sugar level falls. It tells the liver to start putting some glucose into your blood. So I said you have your pancreas tries to keep your sugar at 1 teaspoon in your 5 liters. 12-ounce can of Coke has 12 teaspoons of sugar. So your body didn't evolve to have all of a sudden 12 teaspoons of sugar being dumped in your bloodstream. So the pancreas puts out a huge amount of insulin, and over time your cells get insensitive to that insulin. It's when you have type 2 diabetes comes from. So most of type 2 diabetes is coming from our diets. Even worse is fructose, because that can't go directly into your blood. That has to first go to your liver for processing to be turned into like glucose. The other thing that happens, a lot of it gets turned into fat in your liver, and you get something called fatty liver disease. And in fact, fructose is as toxic as alcohol in terms of killing your liver. Okay, so this is a plot of, let's look at the percentage in the US population with diabetes. So in 1958, it was 1% of the population. Today, it's almost 8%. So that had to all be due to diet. So I didn't mention that sugar is inflammatory. So it causes this chronic inflammation all over the body that's killing cells in your brain, it's killing nerves everywhere. And as I mentioned, that's why diabetics get numbness in their extremities from the nerves being killed. Okay, so you want to avoid sugar, especially high fructose corn syrup. And I'm not saying stop it completely. Most days I don't consume sugar, but if I'm at a party or something and there's cake, I'll have a piece of cake and ice cream or whatever on occasion. So your body's pretty resilient to, a bout every now and then from sugar. But don't do it every day. Definitely avoid these artificial trans fats, vegetable oils, refined carbohydrates. Carbohydrates get turned into glucose, so it's almost like consuming sugar. Excess alcohol and processed foods are usually always bad. They're bad. Let me skip that because we're running out of time. They're bad because they always have sugars added, they have fiber removed, they have trans fats added. So here's just a list of some brain healthy foods. Some we mentioned, some we haven't. The one I like is the dark chocolate. If it's at least 85% cacao, it has some good good properties. And I won't summarize, I just want to put this page up here so it's on the video. So these are some books that cover much of what I talked about today. So I just want to leave that with you in case you want to explore any of these topics in more detail. Some of these are really great, especially like Why We Sleep by Matthew Walker, Carolyn Dweck's book on mindset, and Genius Foods by Max Legavre, or however you say his name. Okay, so I want to thank you for your attention and see if there's any questions on anything. Thank you. Yes?
Okay, thank you very much to the very insightful lecture. So my first question, are this like, okay, so you say something about sleeping at least 8 hours, or having at least 8 hours of sleep. Does this count if, for example, you have 8 hours of sleep, but in a broken format? So let's say like 4 hours, 2 hours, 2 hours, 5 hours, 3 hours.
Okay, so the question is, you want to have 8 hours of sleep every day. Does that have to be a continuous 8 hours? I don't recall. I haven't read Walker's book for a while, so I don't know if it should be in one setting. When it is in one setting, you get that most of your deep sleep that first 4 hours, then that REM the next. I don't know if, well, you slept 4 hours, you got your deep sleep, and if you came back 6 hours later, you slept for 4, do you get your REM sleep? I don't know.
At some point you said that actually power naps in the middle of the day were really useful.
Yes.
I think that's related to that.
Yeah.
Disturbing sleep in the middle of the day is actually helpful.
Right, yeah, that's true. They found that those naps in the middle of the day improve things, and when they would wake people up, they would be dreaming, so they would be getting that valuable REM sleep. Yeah.
Okay, the second question. So with the increase in, let's say, remote work by the professional communities, okay, let me think. If you sleep your 8 hours during the day to work at night, is there any different effects from sleeping during the day, from sleeping at night?
Yeah, so the question is there a difference if you sleep during the day and work at night versus the other? I don't recall. I know that your circadian rhythm is based on light. So if you're sleeping when it's light out, it's probably screwing up your circadian rhythm. And I know if you try to switch when you sleep, like work nights and then work days and then work nights, that's not good. In fact, it's known that when the U.S. goes on daylight savings time, emergency rooms know that they're going to have a lot more heart attacks come in that day. It's because of the change in the sleep. Yeah. Yes?
So this is kind of related to mostly about the lectures you had here last week.
Yes.
When you're talking about different study methods. I think a common trend in there would be like the more uncomfortable a study method is, the more you learn during that process.
Exactly.
But I was wondering, whether those research take into account of the sustainability of people doing those kind of harder way of learning things? Because, I mean, it's like we all know that eating less French fries and you eat celery sticks, you're going to be healthier, but nobody's going to order a celery stick accompanied by a burger, at least not for a very long time. And so when it comes to study, when people studying in the easier way, would they feel more comfortable doing it and doing it more frequently, and actually reap the benefits of some of the other research you're talking about?
Okay, so the question is there a way to have the learning but not do it in the uncomfortable manner where it's difficult, kind of? Everything I've seen, and I'm not an expert in this area by any means, is that anything that makes the learning a little bit more difficult makes it stronger and deeper. And I think there's a guy at Stanford who does a lot of research in this area, Robert Bjork, I believe his name is. You might look at some of his works. I think it's B-J-O-R-K, his last name. So he's the one who's been pointing out that you have to make the learning a little bit more difficult to make it a stronger learning. So you might check some of his papers out. Yeah.
With spacing and repetitive studying so effective and known since 1901, as you mentioned last week,
Yes.
why do we still learn in many of our ECE classes by covering a topic related to the course and then moving on, clustering by type, only to see those topics again on an exam without reteaching? Is this a failure of curriculum design, or is a lack of application to the concepts you discussed?
I think I don't know why we don't have our things structured more with what's known about learning. I know when I became a professor, I had no training in teaching, and I taught for 20 years and didn't know this stuff until I got interested and started looking at the literature and reading it. So I don't know why we don't try to change things. So this is my attempt here to do a little bit of changing things by trying to pass on some of this information. Okay, well, thank you very much.